Hi, we have discussed various factors of a formulation development, including selection of API, excipients, and packaging material in the previous module. In this current module, we'll discuss some more packaging components and its evaluation part while we design our formulation development activities. In continuation with the previous module, we have tabulated about a plastics quality control test for the parental formulations. We have discussed a lot of materials and examples have been given in the previous module. In continuation to the plastics, here we have just listed out what all the test parameters being followed. Basically, any plastic, we know that like a plastic, if you use it for any kind of pharmaceutical applications, you need to assess its performance, because basically it should be a kind of, it should not leak and it should not permeate, or it should not be a transparency, because sometimes it would create a certain kind of photo reactions, and as well as the water permeations. These all are common phenomena, and also like it should not leach, and there should not be any extractable amount. These we know well, as we discussed in the previous model. So as a part of manufacturing, the pharmaceutical industries keep certain test parameters whenever you assess a plastic components. Example, a leakage test where you'll be assessing whether my container closure systems are leak. So there is a specific test which has been defined in most of the pharmacopoeias. You guys can refer those components and what are the methods are available. And compressibility test, collapsibility test, and where you just crush the material and ensure that like how far the packaging material withstands on the compression. And water permeability test for the plastic container, this has been referred in the pharmacopoeias. So water transmissions, which is have to be studied with a certain durations, water vapor transmission permeability test on exposing certain accelerated and humidity conditions, and the vapor permeations will be tested. And clarity of aqueous extract, you can fill the water into the containers and take out the samples and test the clarity, as well as a transparency test to check how your container is transparent in nature. Moving on, a plastic containers for ophthalmic preparations. Similarly, whatever the applications we have done for the parental, the same test will be followed: a leakage, collapsibility, clarity, and non-volatile residues. Non-volatile residues is something when you extract a certain solvent shall be used and fill into the container, and those solutions will be tested for non-volatile residues. There are certain limitations have been provided by USP for the plastics container, and followed by, there is a specific test called systemic injection test, which is intravenous test. So comply with the test described under plastic containers for parenteral preparations. And also you have to check eye irritation test. This test is designed to evaluate responses to the installation of extracts of material under examinations in the eye of a rabbit. So using the selected containers, you have to fill either your placebos or a drug product. Placebo is nothing but there is no active ingredients into the solution. You can check those solutions filled into the container and check for the eye irritation test. And also we are listed a general test on plastic material, a regular test which the appearance, light absorptions, pH, non-volatile matter, residue on ignition, heavy metals, buffering capacities, and oxidizable substances. So these commonly is being used for the solutions which we do an extractions at the required temperature. And based on these confirmations, the plastic containers can be controlled for the manufacturing, and that should be used for your regular commercial productions. Apart from that, there are very important biological tests which has been defined by USP, because a certain plastic components produce a toxicity at certain level. It is very important for us to define the level of the extracts or the level of chemical compounds which could create certain level of toxicity to the user. To minimize, a USP listed out few biological tests, which is implantation test, systemic injection test, and intracutaneous test. The implantation test, a small pieces of plastic material intramuscularly kept in rabbits, and that will be tested over a period of time for muscle irritations and reddening or any other discomfortness. A systemic injection site, injecting elutes using sodium chloride injection with and without alcohol intravenously in mice, and injecting elutes using polyethylene glycol 400 and sesame oil intraperitoneally in mice. These also will test it for these animals and see is there any kind of observations we could make it. If it is so, then there is some risk is involved in the particular compounds. And similarly, it is intracutaneous injections also is being used, and these all will be tested against a control sample. Our control samples would not have any kind of elutes or extracts. And also we have discussed about the metal containers, because metal containers is being used in pharmaceutical industry. In certain level we use as a secondary container for injectable product, because metal is strong, opaque, impermeable to moisture, gases, odors, light, bacteria, and shatterproof. It is the ideal packaging material for pressurized containers we use for aerosols, and we use for certain nasal drops. It is high resistant to high and low temperatures. They includes lubes packs made from foil or blisters, cans, and aerosols and gas cylinders. And we all can discuss little bit on the plastic containers used in tablets dosage form and capsules for the storage purposes. We all very know this. This is renownedly is being used in pharmaceutical industries, which is kind of a screw cap. A plastic material is being used, and it has a multiple layer. If you look at the WAD, has a polymer coating, a foil, a wax, and pulpboard. So these all liners is being used in the closures, and where you can seal the container using certain level of temperature. There are two types of liners is being used. One is homogeneous liner, heterogeneous liner. Homogeneous piece liners available as disc or a ring of a plastic or rubber. It can be withstand high temperature sterilization also. Heterogeneous, these are composed of layers of different material chosen for a specific requirements. Because certain product you may need a thick pad where you have to improvise your pulp board or a polymer coating also. It would give a good permeability also, because I come across there are products which pick the moisture. If you use a thin layer of wads, you have to improvise the thickness of the wad, and also you have to improvise the thickness of the containers. So these are the very major observations where you have to concentrate while developing your product. Factors in selecting a liner. As we discussed in previous slides, thickness are very important, and there are few test parameters which defines your quality of the packaging material, which is a water vapor transmission rates should be low. If it is so, then you will be end up in high permeability, and your tablets would get softened over a period of time. So these all factors you have to consider, and also of course the gas also. And you need a torque required to remove the cap should be optimum. During autoclaving, it should be thermostable. Yeah, it should be in heat resistance, and also it should be stable, should not change the shape during storage, even if the product stored at 40 degrees 75% RH also. So these all have to be studied as a part of development along with your formulation. Apart from this bottles, glasses, plastics, we use a films, foils, laminations. There are multiple packs are being used. We commonly is being observed in market also. A strip pack, blister pack, sachet, and bottles. There are various packaging systems are being used for the commercial purpose. A blister packs which comes with aluminum seals also. And there are PVC, PVD, PVDC packs also used to come, and sachets which comes with alu pouch. So there are various packs are being sold into the market, and these all shall be assessed as a part of development. Foil blisters, when sealed with a metal foil cover, the blister can provide a hermetic pack, that is an isolated systems which excludes any exchange of gases between the product and surrounding atmosphere. Alu foil is the best pharmaceutical package which is commonly is being used. As we discussed, tablets, capsules, which takes place of PVC film, because it won't give a kind of a cracking or delaminations or pinholes. It has a quite a good blocking properties, effectively protecting drugs from water vapor, oxygen, and as well as light. It is particularly suitable for packaging moisture sensitive drugs or those who sold in the hot and humid areas. So it is being commonly used in current market trend. Wherever possible, a foil blisters is being used. And there are tamper evident packaging, which is tamper resistant packaging they call it. A tamper resistant package is provided with an indicator or barrier before entering the package, so that if this indicator or barrier is broken, the buyer immediately gets the evidence that the product has been opened or tampered. We all know this is regularly not only in the pharmaceutical industries, most of the products you could see any product, even nowadays, the mobile phones also comes with a tamper evident where the user can see that whether it has been opened by someone or not. The following packages are approved by FDA as tamper resistant packaging systems. A list have been presented here. A blister, strip, bubble pack, string seals, foils, etc. etc. So these are an examples presented for your information and understanding. Tamper resistant packaging, there are various applications also, cosmetics and dermatological products also. The both ends of the tubes are sealed. The mouth or blind end must be punctured to obtain the product. A tube with the crimped end is acceptable if the crimped end cannot be breached by unfolding and refolding without showing visible evidence of tampering. Direct printing of the label on the container is preferred to using a label that could be removed and substituted. So these are an example to see in the market how this tamper evident is being used. And various tubes, dermatological products, and ophthalmic drops we come across by seeing a tamper evident is being used. There are certain quality control tests. It's a common test which we have seen for the packaging, and similarly a collapsible tubes also will be studied for the leakage test, a lacquer curing test, which is inclusion of power of adhesions and flexibility test. So maybe you can get into detail about how this test would be done. I don't want to take it further. And lacquer compatibility test, in that a product compatibility and as well as the lacquer compatibility will be studied. Quality control of strip and blisters. Leak test is a majority is being used. You can seal the container. Of course, this is a similar test for both parenterals and as well as a blister pack is being used. It's a kind of a vacuum test. Sometimes you can generate certain amount of vacuum and see that are we getting any kind of deformations. So the contents of the strip and blisters packages were removed and the presence of moisture was checked. If there is no leakage, the contents will not be wetted. This indicates the perfect sealing of the package. It is being commonly used even in the parenterals where they use it with the methylene blue, or they can use certain kind of a litmus paper to tag the containers and generate certain level of vacuum and observe that is there any kind of change in color or leakage by using a methylene blue dye inclusion test also. Rubber also is a component is widely used. There are multiple products you can see, particularly on injectables and nasal drops. The rubber components are widely used. Rubber components has certain characteristics, and there are certain chemical components also is being used to manufacture the rubber components. It is very important for us to test the leachable and extractable of the rubber components which is being used into the formulations. The rubber components also comes with a coated or uncoated. The problems what normally we use it certain times it would become brittle over a period of time, and risk of product absorbing, which is nothing but extractions or leaching. It has certain degree of moisture and gas permeation too. A rubber having two different varieties. One is natural and another one is synthetic rubbers. Nowadays, the synthetic rubbers are being used, have fewer additives and thus fewer extractables and tends to experience less absorptions of product ingredients, are less suitable for repealed insertions of needle because they tend to fragment or core, pushing small particles of the rubber into the product. Example, silicon, butyl, bromobutyl, chlorobutyl, etc. Silicon is least reactive, but it does experience permeability to moisture and gas. A butyl stoppers, which is call it bromo or chloro, which is nothing like fluorobutyl stoppers, is being used with coated of a Teflon or a kind of fluorotec coated. These all stoppers is widely used in an injectable and is being studied for is quality controls, kind of non-volatile residues, a turbidity test on the extracts, pH change, elemental impurities from an extracts, and certain level of known components by using LCMS techniques to understand the level of impurities on storage. It is very important to define any kind of leachable components, call it as analytical evaluation threshold, by the technique is being followed by USP, and also it clearly defines the guidance what is the level of the impurity need to be kept in. So butyl stopper. Butyl stopper, it has very good permeability to low water vapor and air. Water absorption is very low. They are relatively cheaper compared to other synthetic stoppers. These are copolymers of isobutylene with 1 to 3% of isoprene or butadiene. After vulcanizations, butyl stoppers possess virtually no double bond. Consequently, they are most resistant to the aging and chemical attack. And of course, there are few stoppers which is nitrile rubber, chloroprene stoppers, and silicon rubbers. Chloroprene, these are polymers 1:4 chloroprene is being mixed due to the presence of chlorine group close to the double bond, so that the bond is resistant to the oxidation. Hence these stoppers age well and it's stable well. Water absorptions and permeability are less than for natural stoppers. Of course, silicon rubbers extremely low absorptions and permeability of water, excellent aging characteristics due to their saturated chemical structures. So with this, we will be closing. Most of the packaging materials were discussed, and what are the factors are being involved as a part of development. We have discussed plastics, we have discussed glass, rubber stoppers, aluminium, and etc. So we can discuss further on few components and certain process characterizations in future module. What are the important studies to be generated for each dosage form? Wish you Good luck.